Ah, the multiverse. Is this thing for real? I mean, is it a mind-bending new frontier of physics, or is it just a fantasy? It's an idea that springs from some of our deepest, most fundamental theories about the universe. But, and this is a big but, it comes with a pretty heavy accusation that it might not be science at all. So let's find out.
All right, let's really get into it. Is the whole multiverse idea just a wild, unscientific shot in the dark? Or could it actually be a true description of reality? We're going to put it on trial. Yep, that's right. We'll explore the case for and against, and we're going to see if it can hold up under some serious scientific scrutiny.
Okay, so our investigation really kicks off with a genuine cosmic mystery. And it's a big one. The fact that you and I are even here, well, it seems to be against some absolutely incredible odds. Why? Because our universe, it seems to be perfectly, and I mean perfectly, calibrated for life.
So what does that even mean, calibrated for life? Well, it means that the fundamental constants of nature, the numbers that literally define our reality, are balanced on a razor's edge. Seriously, if you tweak them by even the tiniest fraction, the universe as we know it, it just couldn't exist. Poof, gone. And the sensitivity we're talking about here is just astounding. For instance, if dark energy was just a tiny bit stronger, the universe would have expanded way too fast for galaxies to ever form. A little weaker? And the whole thing would have collapsed back on itself. Or what about the Higgs boson's mass? If that were different, atoms themselves might just fly apart. It really seems like in almost any other possible setup, we just wouldn't be here to even think about it. So, how in the world do we explain this apparent fine-tuning? Well, one of the biggest, most talked about explanations is, you guessed it, the multiverse. And it works hand in hand with this other big idea called the anthropic principle.
Okay, but first, let's get our terms straight so we're all on the same page. In modern physics, when scientists say universe, they're often just talking about our own cosmic bubble. Everything that expanded from our Big Bang. It's kind of like our local patch of reality.
The multiverse, then, is a hypothetical collection of all these different universes. Think of it like a huge cosmic ensemble, where every single bubble could have totally different physical laws and constants. Yeah, some might be like ours, but let's be real. The vast majority would probably be sterile and empty.
And look, this isn't just some random guess somebody pulled out of thin air. The multiverse isn't an idea that was invented just to solve this fine-tuning problem. It actually emerges naturally. It's a prediction from some of our leading theories, like eternal inflation and string theory. The multiverse literally just pops right out of the math.
And to put this into perspective for you, just one of these theories, string theory, predicts a cosmic landscape with an almost unimaginable number of possibilities. We're talking about 10 to the power of 500, that's 10 to the 500, different potential universes, each with its own unique physics. That's a 1 followed by 500 zeros. I mean, you can't even write that number down without your hand cramping.
Right. And this is where that anthropic principle thing I mentioned comes in. It's basically a selection bias. Think about it this way. We find ourselves living in a universe that can support life for the exact same reason we find ourselves living on a habitable planet instead of, say, Jupiter. It's not that the universe was designed for us, it's just that we could only have shown up in one of the super rare universes where the conditions were actually right for us to exist.
Okay, so on the surface, the multiverse seems to offer a pretty neat solution to that whole fine-tuning problem. But this is where the critics step in, and they come in swinging, leveling two major charges that lead a lot of people to dismiss the whole idea as totally unscientific.
So charge number one, it's unparsimonious. What does that mean? It violates Occam's razor. The idea that we shouldn't just make stuff up beyond what's necessary. And let's be honest, what could possibly be more making stuff up than a near infinite number of universes? Then there's charge number two, it's unfalsifiable. If we can never ever see or test these other universes, is it really science or is it just philosophy?
And those are really serious charges, right? They strike right at the heart of the scientific method itself. But the story doesn't end there. The people who support the multiverse idea, they have a powerful defense. So let's hear what they have to say.
All right, let's tackle that first charge. Does dreaming up countless universes really violate that principle of keeping things simple, Occam's razor? Well, the defense argues that this is a huge misunderstanding of what Occam's razor is even about.
See, the principle isn't about minimizing how big or how many outcomes a theory predicts. Not at all. It's about minimizing the number of assumptions or causes in the explanation itself. You could have a very simple, very elegant theory, one with just a few moving parts that leads to an incredibly vast and complex result. From this point of view, the multiverse isn't the assumption, it's the result.
And you know what? There's a historical pattern here. Time and time again, our gut feeling, our bias for a small, cozy little cosmos has been dead wrong. The ancient Greeks, they rejected a moving Earth because they just couldn't imagine the stars being far enough away to not show parallax. Even as recently as 1920, the astronomer Harlow Shapley argued against other galaxies because the whole idea made the universe, and I quote, uncomfortably large. It kind of seems like our comfort level isn't a great guide to what's actually real.
So here's the key takeaway from the defense's side. The simplicity of the multiverse theory really comes down to the simplicity of the underlying theory that predicts it, like string theory or eternal inflation. The sheer bigness of the prediction, that itself isn't necessarily a violation of Occam's razor.
Okay, fine. But what about that second charge, the one that's arguably even more damaging? If we can never, ever get to these other universes, doesn't that make the whole idea unfalsifiable? And if it is, isn't it just not science?
Well, the defense's response here is pretty direct. That claim is just not true. Look, while we may never be able to pack our bags and visit another universe, that doesn't mean we can't find evidence for them or test the theories that predict them. Testability can be indirect, you see.
For example, right now, some scientists are literally looking for cosmic bruises in the cosmic microwave background, that faint afterglow of the Big Bang. These would be potential signs that our universe actually bumped into another one. But the test can be even more subtle than that. If a theory predicts a multiverse, it can also predict which physical constants are more likely to pop up than others. And this is exactly what allowed the physicist Steven Weinberg to make a stunningly accurate prediction about the strength of dark energy. He basically argued that its value should be just right for life to form. And guess what? He was right, years before anyone was able to measure it.
So, there you have it. We've heard the prosecution, we've heard the defense. We've weighed the charges, that it's too complicated, that it's untestable. So where do we land? Is the multiverse just bad science?
Well, the verdict is a little nuanced. The idea of a multiverse can be bad science, for sure, especially if it's just used as a lazy philosophical escape hatch to answer the fine-tuning problem without any real mechanism behind it. But, and this is a big but, it can be good science if it emerges naturally from a concrete, simple theory that makes other testable predictions about our universe. And that right there is really the heart of it. The scientific legitimacy of the multiverse isn't about the wild idea itself, but all about the rigor with which it's pursued. As long as it's treated as a testable prediction of a fundamental theory, it stays firmly within the realm of real science. And so, here we are, at a crossroads. Is the multiverse an explanatory dead end, just a scientific fantasy? Or could it be the next great frontier, pointing us toward a totally revolutionary new understanding of our place in the cosmos? Honestly, the jury is still out, but the trial itself is one of the most exciting things happening in all of science.